Figure shows a graph of particles position along the x-axis versus times it's moving, you know. So it's distance against time. Sometimes they'll say x, normally it's distance. What is the sign of the particle's position? Is the particle's velocity positive, negative, 0? What is the sign of the particle's position? Okay, like between 1, like, is it from our frame of reference? It's actually far away, it's not starting at 0. So here's how this problem is kind of shaped. All right, let's bring this in here. Okay, so what's happening is the ball is actually moving towards the right hand side like so. But you're measuring the ball from this region. So even though it's moving closer to you, this region, this distance will be in negative. And again, the frame of reference is like this way is positive, right? And this ball is moving towards you. So you see it's far away and it's in the negative region because, of course, before this line, any distance measured, it will be negative, measured in negative. So -1, -2, -3, -4, probably at -3. And it's moving, but it's, look at the gradient. The gradient is the velocity and it's slowing down. Why? Well, to start off with the velocity, let's still talk about the velocity. That's the distance. Distance is moving like that. Velocity is also moving like that. Velocity is also moving like that, but it's decreasing. And that tells us that the acceleration is actually against the velocity because it's decreasing. So the acceleration is actually towards like that. And we see there's the gradient is constantly decreasing, and it keeps on decreasing as you go down. So the acceleration is probably constant because in A levels we deal with constant acceleration, right? Nothing too fancy. So acceleration is constant, but towards the negative, right? And velocity is positive but decreasing till here. Then it's decreasing, then it's negative and increasing, right? After it reaches point 2. Point 2 will be somewhere here, somewhere like this, somewhere here. It'll slow down and reach till that point and it's going to go backwards, right? Sorry, at time 2. That's time 2, not distance 2. Sorry, my bad. At time equals to that value. So at time, not distance. Distance is probably just 1 because we see it over here, right? Time 1 second. Let's also put the second in here. Okay. All right. So at time equals to 0, what is the particle's position? Let's actually answer the particle's position for each bit, and it's not numbered, so we'll assume this is each this each height is 1, so that's -1, -2, -3. So for A, the particle's position is -3 meters. Is the particle's velocity positive, negative, or 0? And the velocity is actually positive but decreasing, right? So it's positive. At t equals to 1, the particle is at 0 meters and the velocity is still positive. At t equals to 2, the distance is actually 2 meters and the velocity is 0. So it's not positive or negative, right? At d equals to 3, it's at 0 meters again, but the velocity is now negative. And it's gonna stay negative for eternity after this.